Do you know how fluids are pumped from your sewage system even with suspended solid particles in it? Centrifugal pumps with semi-open single-vane impeller can be the suitable solution for this application. In this video, we will have a conceptual overview of the working principle and kinematics of this pump design and understand why it is suitable for applications in wastewater treatment, agriculture, oil and chemical industries in 5 minutes. Pump components. Every pump has an impeller. In the case of single-vane impeller, the impeller blade could be built up from a simplistic curve. One side of the blade is attached to a shroud, giving it more mechanical strength. The other side of the impeller is open. This is why the design is named semi-open single-vane impeller. When the pump is in operation, the impeller rotation facilitates the action of centrifugal force on the fluid and creates the flow. Another main component of the pump is the volute casing, which helps to navigate the fluid flow from the inlet to outlet. An important thing to note here is that the increasing area of cross-section of the volute. There are still other important components inside a pump such as bearing or sealing. However, these components are outside the scope of this video. Working. The liquid that needs to be pumped is collected through the pump inlet and the impeller is usually immersed in it. When the impeller rotates, it also imparts centrifugal force to the particles of the fluid and thus causes the surrounding liquid to rotate. In this way, the rotational mechanical energy is converted into the energy of the fluid. The fluid, when goes out of the impeller, will continue to move along the volute wall towards the outlet. The progressively increasing shape of the volute accumulates fluid at the discharge end and thus increases the static pressure. Meanwhile, at the suction end, this displacement of fluid causes negative pressure. This draws in more fluid into the impeller and continues the process. Due to the huge spacing of the impeller blade, single-vane impeller allows the passage of small particles and slurry suspended in the fluid, thus reducing the risk of clogging. Kinematics. In this section, the kinematics of the fluid and the pump is explained. The study of different components of flow velocities is important to understand the kinematics of the pump, and this is done graphically using velocity triangles concept. These velocity triangles can be drawn at any specific point of the flow path. The flow described with respect to a fixed reference frame is said to be absolute, and the flow described with respect to a rotating reference frame is said to be relative. So, the velocity of the fluid observed from the casing, which is a stationary reference frame, can be called as absolute velocity V, and the velocity of the fluid observed from the rotating impeller can be called as relative velocity W of the fluid. We can say that the relative velocity takes into account both the absolute velocity of the fluid and rotational speed of the blade. Hence, the blade velocity U, which is the result of the rotation of the blade, can be defined as the product of angular velocity omega with the radius of specific point of the blade. The relative velocity W is given by V minus U. In a rotating device, the relative velocity should be tangential to the blade profile for smoother flow. Now we know how to calculate W and U. We can calculate V by rearranging the above equation to V is equal to W plus U. So the vector V is the resultant of vector W and U. This vector triangle formed by these following vectors is called velocity triangle. The velocity triangle can be drawn at the inlet in a similar fashion, and these help us to do flow calculation for the pump, which is essential to determine the main dimensions and blade angles of the impeller for a specific pumping task. Comparison of impellers. There are several types of centrifugal impellers, normally classified by the number of vanes and shroud configuration. Generally, impellers with high number of vanes are not suitable for handling cloggy fluid due to the small clearance among vanes. Meanwhile, the impellers with low number of vanes as a single vane perform well in this aspect. The shroud configuration also plays a role in mechanical strength of the impeller, which is important to the stability of the pump. To strike a balance between clogging and strength, semi-open impellers with fewer vanes or even single-vane impellers can be employed. Comparing flow rates. Single-vane design can support higher volumetric flow rates compared to multi-vane design as it has much more free area, reducing obstruction to fluids. However, multi-vane impellers can provide smoother flow as the fluid gets distributed more evenly among multiple vanes. Comparing maintenance, wear and tear. Open and semi-open are easier to inspect and clean. Closed impellers have a longer lifespan and better resistance to wear due to reduced exposure to solids and abrasive particles. Summary. In this video, we have discussed typical applications, the main components, the working principle, the basic kinematics, and the comparison with other impellers. Thank you for watching the video.